Just waiting for the recording to start. All right, recording is started. Today is Tuesday. We have our Unit 1 review. You're all very excited about this. All right. So I have a meeting at 11, so we have to make this relatively quick compared to past lessons. All right. Make sure you have your pen, pencil, and then at the very end, I will give you a link. You can download this. For people who are here. All right, so arithmetic sequence. The first term of an arithmetic sequence is -16. The common difference of the sequence is 7. What is the sum of the first 20 terms of the sequence? Well, this is just a plug and chug problem. On this page, I gave you 2 equations. You can either use this first one. So this is for an arithmetic. This is if you have the number of terms, the first term, and the last term. If in the problem it doesn't give you the first and last term, which it doesn't, it gives you the first term and the common difference, which is 7. So we wouldn't use this one. We would use this one. N divided by 2 times the quantity 2a sub 1 plus the quantity n minus 1 times the common difference. So I had some people ask me throughout this unit, kind of going over the quizzes and stuff, people are using the wrong formula. So if your summation formula, your S sub n, has the variable r in it, what does that tell you? It is geometric, yes. The r is the common ratio. It is for geometric sequences series only. If, in this case, it has the variable d in it, so that is the common difference, which is only for arithmetic sequences and series. Keep that in mind. Some people were just picking out, they saw, oh, S sub n, that's sum, so it has to be this one. Well, remember, there's summation formulas for arithmetic, geometric, finite, and summations for geometric, infinite. So you want to make sure that you actually grab the right formula and you understand what's going on. You know, you should understand common ratio is geometric, common difference is arithmetic. You should recognize if your sequence is geometric infinite or geometric finite. It is a big difference. This is arithmetic. So we use that second equation on the page here. We just plug in our stuff. And hopefully I plug in the right stuff. And then we just do the maths. We math it. So I would highly recommend all of you who are watching this live, after we're all done with this review, go back, redo all these problems. Make sure that you get the same answer that I get without looking at the work. He's looking at my work and say, oh, I could do that. You do the test and you make some really simple mistakes and then you miss all these problems because maybe you didn't type it in right or something to that effect. So hopefully all of you are doing these again. And if you're watching the recorded session, hopefully you are pausing this video, working this out to see if you get the same answer. And I sent everyone an email. I am downloading these and I'm putting them on this class's YouTube channel, and it's in a playlist. So it'll easily, you can go to YouTube, you go to this, you play the video, you can pause the video, you can play it at faster speeds. So everyone should have got the email from me. I think I sent it last week. All right, questions on this one? Right, second one. What is the value of the series represented by the summation from n equals 1 to 5 of the expression 2n quantity raised to the n minus 1. So this tells us that we are starting at 1. So this variable right here, this could be anything. This could be just like on your quiz, I think from this either 102 or 103 quiz. Your n started at, I think it was 2, and it went to 6, I think, 2 to 6. So just be careful. All of you should have obviously done your quizzes. You got 3 attempts at those. All of you should have got 100% by your third attempt, or an 80, right? At the lowest. All of you should have done the learn and practice module examples. Whether or not you read what it's trying to teach you, because I try to cover everything that they do, just make it simple. You should at least do the examples. And I know I say this a lot. And I think a lot of you are tired of me saying it, but I still have to say it because a lot of you are still not doing the examples in the practice or the learn modules. It drives me nuts. All right, so we start at n equals 1. We plug that into here and here. We write that down. Then we go to n equals 2, 3, 4, and then 5. So this tells us where we stop. So n equals 1, 2, 5. 1, 2, 3, 4, and then 5. If that was a 3, we would say 3, plug it in, 4, plug it in, 5, plug it in, stop. All right, so there's the work. Hopefully I typed it correctly. Does that look good, guys? Can you confirm? All right, and then we just do the math. And yeah, and then get these sweet numbers. And then the final answer is 10,551. Test is looking pretty easy so far. So if you notice, I am putting the lesson and what day it was, because 102 was 3 days and then 103 was 2 days. So if you notice, this exam is mostly 1.02, whether it's day 1, day 2, or day 3. A lot of it's 102. Someone said they got 10,553 in Desmos. Did I mistype it? Someone else confirm that I'm right or wrong. Type it in, people. Sarah, what did you get? Oh, it's 10,553. Oh, I mistyped it. That should be a 3. Yeah, that's a sweet 3. I used my head. 6, 4, 10, 2. Yeah, it is 3. I don't know how I got a 1. Whoops. Thanks, Antonio, or whoever wrote that. Yep. So made a mistake. See, look, you know what? I did all that great work, and I had the wrong answer. That means I would have entered that in the test, and I would have got 0 points for my efforts. Right. I heard somebody talk. Make sure that if you do not want to be on mic, your mic is muted. All right. So this is from yesterday's lesson, I think. No, yeah, yesterday's lesson. So using Pascal's triangle. All right, so we have wants to know what is the fourth term in the expansion of this stuff all raised to the 10th power. It is 1013. Let's go ahead. I want everyone to try this problem. I'll give you guys, I think we can spare 2 minutes. Remember, I have a meeting at 11, so we'll say 2 minutes. I want everyone to try this one. The answer is not covered for you? Oh. Yep, that's new row. Well, if it's not covered for you, let's pretend it is. On my side. Got another 50 seconds to finish this problem. And look, I even gave you the coefficient. I pointed Pascal's triangle. I obviously snipped the row we wanted. This 10 tells us we want to use this row. And because we're finding the fourth term, we just count first term, second term, third term, fourth term. So that should be a 120 right there. See, I got you started. Oh, time's up. All right. 120. All right. In your final answers, what is the coefficient part? What number is that? Go ahead and type that number. The final answer. And the final answer, what is the coefficient, the number part? Anybody finish? Question is, did anybody try this problem? Start there. Anybody try to do this problem? Okay. People tried. Go ahead and chat. Go ahead and write down what you think the number portion of the answer should be. Somebody says negative 320 over 729. Anybody else get negative 320 over 729? You know what? It is negative 320 over 729. Do all of you just need more time? Was 2 minutes not enough? It probably wasn't. That's okay. Go through it. So we write the first term stuff. We write the second term stuff. All right. So everyone should be good on this step here. Again, the 120, because we're doing the fourth term. We take this stuff, we put it here. We take this stuff, we put it here. All right, everyone should be good from this point. All right. The exponent for here, we count down. So this would be starting at 10. It goes 10, 9, 8, 7. So this should be a 7 underneath this box. Let's see if it is. It is a 7. All right. And then this number, well, should be counting down from this direction, starting at 10, 9, 8, 7, 6, 5, 4, 3. That number should be a 3 right there. All right, everyone's good so far, and then we just do the math. Well, this is where some of you need to review some power properties. Now, I sent you guys a YouTube video. I sent you two. Well, I sent you a bunch of like 3 links, right? Last week about make sure you review this. One was about the power properties, in particular, power to a power property and the quotient power property. So I said watch those from that video. And then I also had you watch the factorial video, which is actually, that was a really good video. The person did that video did a really good job. All right, let's go on. So you have 1/3, an x, and a y. So you have to power all 3 factors. 1/3 to the 7th, x squared to the 7th, y to the 7th. All right, so in fractions, when you have a fraction to a power like this, you are doing the power of 7 to the numerator and the denominator. Well, what is 1 to the 7th power equal to? 1. Yep. And then 3 to the 7th power is some bigger number. 2187. So if you forgot how to deal with fractions and exponents, there you go. Then power to a power, what do we do the 2 and 7? Multiply, so you get 14. And then that y is just y to the 7th. Right, easy. Yep, pow, multiply now. That's right. All right, so right here, what is -2 to the 3rd power? -8. And then what is 3 times 3? 9. Yep. That 120 carries down. And then we just put stuff together. So for the number part, 120 times this fraction times -8 gives you this number here. Remember, this is all multiplication. So 120 times 1 over 2187 times -8 gives you this nice fraction. And then you have x to the 14th. There's no other x's, so that's just going to be x to the 14th. And then you have your y to the 7th and y to the 9th. So same bases. When multiplying, what do we do to the exponents? You add them. So what is 7 plus 9? 16. Yeah, and that's how you get to the answer. This problem is not bad if you know your exponent rules. Yeah, if you know your exponent rules, it's pretty easy. All right, let's keep going. Anyone 87? Let's take a look. So going back, you do 1 to the 7th power on top and 3 to the 7th power on the bottom. And 3 to the 7th equals 2187. All right, infinite series and segment notation. It says, what is the limit of the infinite series? So was limit? Well, I give you this, and we just use a whole, top heavy, bottom heavy, even stuff. Well, n squared and n squared, they're the same. So we do what? What is the well, first I rewrite it as a limit, right? So I just rewrite them all in limit notation. And then we look at the exponents, they're the same. So what is that limit? Careful, careful. There is a negative sign right here. It is -3. Yes, be very careful. Um, your test likes to put the negative right in front of the fraction. I personally don't like that. I like having it in the numerator. I'm doing it this way just because if you type your answer, if you have a fraction, you put that negative on top instead of in front, it grades it as wrong. I think it's insane. It's not smart enough to give you credit if you put it on top, even though it is right. But anyway, so yes, you take the ratio of -3/1, and that's why it is -3 for the limit. The limit is -3. The next one looks like it's bottom heavy, so n squared on the bottom and on top. So if it's larger in the denominator, what is the limit? Limit is 0. Yep, it goes to 0. And lastly, if the exponent is larger in the numerator, n cubed versus n squared, what is that limit? The limit is none. Yes. So remember, because the exponent is larger in the numerator, there's no limit. Well, me saying none means that it goes to infinity or negative infinity. So your test may actually have, if it's multiple choice, may have infinity, or it might have none. They mean the same thing in this situation. By saying there's no limit implies you're going to infinity, and saying it goes to infinity implies that there's no limit. So hopefully you understand that. Saying none doesn't mean it doesn't exist. That's totally different. So be careful. Your test might actually have it. I know on your quiz for a fact it didn't say none. It actually had infinity symbol. Okay, next one. Arithmetic sequences and series. What is the 83rd term in the arithmetic sequence? And I give you this stuff. All right, what do we have to do first?
They're asking how to know when to do the ratio test.
I'm going to answer your question. So, a question was, how do we know when to do the ratio test? I will answer that in a couple slides. So, I do tell you it is arithmetic. So I said arithmetic sequence. So right away, I'm telling you what it is. I'm telling you it's arithmetic. So there's no figuring it out yourself, which is nice, right? So what do we do? Find the common difference. Yep. And how do I find the common difference? Subtract. Remember, division is for the common ratio. You're subtracting. What are we subtracting? What from what? A sub 2 minus A sub 1. Yep. So negative 106 minus negative 117. Remember, arithmetic is common difference. Geometric is common ratio. So we get 11. And then we just plug it into the formula, which I provided on this page. And hopefully I type it in right. Oh, 785. All right, we good? Reluctant, yes. Okay, write series and sigma notation that represents this. So you got 1 plus 1/4 plus 1/9 plus 1/16 plus ... up to plus 1 over 121. All right. So we know we have to put the little Greek e, sigma. We know we're starting at n equals 1. So somebody says, Chloe says that the index, we are going to 11. How do we know it's okay? So we're kind of jumping ahead. What's the actual expression that represents this? I'm going to give you a hint. This one is not geometric or arithmetic. It's something else. So square roots. 4, 9, 16. Well, I don't know about square roots. Squared. Yeah, squared is probably better. Yeah. Squared. So looks like, how do we get 4 here? What squared is 4? Yeah, 2 squared is 4. What squared is 9? 3. What squared is 16? Yeah, 4 squared. What squared is 121? Ooh, 11. So that's probably how we got 11. So to make this a fraction, divided by, is 1 squared still 1? Yeah, it is. 1 by 1 is still 1. So it looks like, what is the expression then? What's the equation we have to create? What is that expression? 1 divided by n squared. Yeah, is correct. Divided by n squared. And you can always, once you create this, just check the first 3 or 4 to make sure that you get these numbers, and we do. And then we can see really easily that this is 11 squared. So that means that this goes to 11. The one on your test is also really simple. It's a really simple pattern. It's not going to try to confuse you. It's probably if this was considered easy for you, the test will be easy also. Try to make my examples same difficulty as what you see on the test. All right, let's keep going. We got about 29 minutes left and we're halfway done. Okay, the first term of a geometric sequence is -500. The common ratio of the sequence is -0.5. What is the 10th term of the sequence? Well, I give you common ratio, and I tell you it's geometric. So we're going to use, and we want to know the 10th term. So we want to use this formula right here. This is the particular term formula. I give you the first term, I give you the common ratio, and I give you the n, which is going to be 10. So you plug all that stuff in. And there's the answer. Why is my answer in decimal form? Why? Why is it decimal? Because I started with decimal. Yes, people listen to me when I talk in class. Yes. The answer is decimal because we started with decimals. Yeah. Yeah, if it gives you the common ratio in decimal form, it expects you to write your answer, your final answer in decimal form. You know, hint, hint. All right, let's keep going. Hopefully I type that in right. So your test has two of the same type of questions. So if you notice, we just did this problem. It was asked a little different, though, a little differently. Um, but it's honestly the exact same question. The nth term of an infinite sequence is represented by this stuff. What is the limit of the nth term as n grows increasingly large? It's the exact same question, just asked differently. So I just put the same question down or the same examples. So we write it. So before it was in sigma notation, and now it's not. It's in this particular term notation, but it tells you that it's an infinite sequence. So we just rewrite it as a limit. Nothing's different, and we use the same rules. Nothing has changed. All right. Hey, we got the test of convergence. Test the following series for convergence. Now, Chloe asked me earlier, how do we know when we do the ratio test? Well, here you go. To test for convergence, we cannot use if the basic arithmetic or geometric rules. We can't use if the power is larger in the numerator or denominator, because in this case, the power has a variable, and that tells you we have to use the ratio test. So, oh, I uncovered the answer. Oh man, you guys can see the answer. Let's pretend nobody saw that. Nobody saw that. Anyway, so we do the ratio test here. First, you got to find. You just write your a sub n, and then you got to write your a sub n plus 1 by plugging in n plus 1 to all of the n's. That's what I did. And then we simplify. No, someone told me to wait, so I stopped. All right, we good? We good up to this point, guys? All right. Caitlin, what's going on? Oh, never mind. Okay. All right, and then we do the setup. And then a fraction divided by a fraction, we just flip and multiply that bottom fraction. All right, so it looks like 6n plus 7 and 6n plus 13, these are already in factored form. I can't do anything to help me cross stuff off, so I'm just going to uncover those boxes in the next step. We can't do anything else with them. But using exponent rules, we have -1 raised to n plus 2 and -1 raised to n plus 1. If I can get these exponents to be the same, I could cross stuff off. So which one should I change? Which one should I make look different but have the same value? Top one. Yeah, the top one. So what should I do to this exponent? I should... Yep, I should subtract one of them out. So I should write it as n plus 1 on one of them and 1 on the other. So I am just subtracting one exponent out. Again, this n plus 2, I subtracted 1. And I wrote it separate. So if you think about it, remember, same bases, you add exponents. Is n plus 1 n plus 2? Yes. Always ask yourself that. Do these exponents add up to what I started with? Is n plus 1 n plus 2? The answer is yes, which means I did it correctly. All right, so then from here, these now match. So I am going to cross this one off and cross this one off. Oh my gosh, I can't even do a straight line without freaking out. All right. So that leaves us with, what is -1 to the first power? -1, yeah. I'm not trying to trick you guys. And we got this stuff, and then that's a 1. And we put it all together. Don't forget, with the distribute, -1 times 6n, -1 times 7. That's how I got this right here. Do not forget to do that step if you have that on your test. Though it's really not going to matter because it's the absolute value. So we do the absolute value of, remember these, now we look at the exponents. N to the first power, n to the first power, they are the same, so what do we do? How do I find that limit? The ratio, yeah, the coefficients. So I do -6 divided by 6. Remember, it's absolute value, so that's why I kept them positive, and that gives us 1. So the limit of this goes to 1. So looking at the rules of convergence for the ratio test, looks like it matches this one here. Because it equals 1, it means, well, the test is inconclusive. So there's the answer. It is inconclusive. So the R value is 1, which tells us it is inconclusive. I recommend that all of you look at the examples from the lesson we did, and also the examples from the Learn and Practice modules. All right. Consider the series. Do the series converge or diverge? Well, I'll give you a little things down here, and I say arithmetic series are always divergent. So if it is arithmetic, it's divergent. Geometric series are convergent if the absolute value of the common ratio is less than 1. So we have to determine, is this arithmetic or geometric? So negative, positive, negative, positive. Well, they flip-flop, positive, negative. So right there, it tells you it can't be arithmetic. So the common ratio, how do we find that? 4 divided by -3. Yes, you are correct. -4 divided by -3 is this -4/3. And you could also do -16/3 divided by 4 to verify we get -4/3, and we do. All right, is -4/3, is the absolute value of this, is that less than 1? It is not. Yeah, it's 1.33 repeating, so that is definitely not less than 1. So it does not meet this requirement, so it's not convergent, which means it is divergent. So it diverges using this little rule here. All right, this next one, we got -2, -5/3, -4/3, -1. Okay. If it's arithmetic, what is the common difference? 1/3. We are adding 1/3 every single time. You are correct. Yep. So to do that, negative 5/3 minus -2 is positive 1/3. Negative 4/3 minus negative 5/3 is also positive 1/3. That's why you always want to check at least 2 or 3 to make sure. So if you guessed geometric and you did negative 5/3 divided by -2, you got an answer. You did negative 4/3 divided by negative 5/3. That answer wouldn't match your first answer, which tells us it's not geometric. And because it is arithmetic, by definition, it diverges. These all arithmetic sequences diverge. Okay, what is the sum of this infinite geometric series? So look, I say it's geometric and I tell you it's infinite. So somewhere in your notes, actually in 1.02 day 3, there is a formula for the summation of an infinite geometric series. You want to use that formula. Remember, there is a formula for geometric finite series. Don't use this. Don't use that one in this scenario. This is infinite. So that formula I went ahead and put right here for you, but you can find it in this lesson. First, you find the common ratio, which is, well, that. Then you plug the stuff in, and then you get this. And we're done. All right, we good? Okay, next one. Determine the geometric means between 3 and 27. So I tell you it's geometric. So we are multiplying by some number every single time. I give you the first term and I give you the fifth term. So we have to do some work. We got to find the common ratio for one. All right, n is 5, right? So a sub 5 is equal to a sub 1 times r to the 5 minus 1. So I'm going to use that formula. And then I plug in a sub 5 is 16 over 27. That goes here. A sub 1 is 3, so that goes here. Then 5 minus 1 gives us 4. So there's the setup. We're going to divide both sides by 3. And that's how I get 16 over 81. We are then going to do the 4th root to both sides. And that's how we get r is 2/3. Okay, so how do I find the 3 blanks? What do I do? What happened?
So up top here, you end up putting 27 when it's 16 over 27.
I'm confused.
All right. So in this question here, you put 16 over 27, right?
Yeah, that's here. That's right.
But over here, you put 27. You put 3 and 27. That's why I fixed it.
Oh yeah, okay. Yeah. Thank you for doing that. Yes, thank you. But the work is right. Yeah, work is right. That's why I was confused. Okay. I'm blind. I didn't see you actually write that. All right. So how do we find these missing terms? What do I do? So one person says plug it in, I'm guessing to that formula on the bottom. Someone else says multiply the first one by the ratio. Both are correct. Yeah, so we could use that formula on the bottom and we just plug in 2, then 3, then 4. But that's the long way. The easy way is because we now know the common ratio. I don't have to use this formula. I just multiply the previous by the common ratio. So let's do 3 times 2/3. That gives me 2. So there's your other one. So I'm going to cover that. I then do 2 times 2/3, and that gives me 4/3. I then do 4/3 times 2/3, and I get 8/9. And then just for completeness, I'm going to do 8/9 times 2/3 to make sure I get 16/27. And I do. And that's a good way to check. So at the very end, you should get that last number if we did it right. So the blanks would be 2, 4/3, and 8/9. These three right here. Pretty neat, right? Okay, so that was your test. Not too bad. And a lot of it's kind of like drag and drop or fill in the blank. Yeah, the way it presents, like entering your answers, you'll see it's pretty simple. Again, so guys, make sure you guys go back, redo all these problems without looking at the answers to make sure that you can do them, along with enter them in your calculator to get the right answer. Because a lot of times people miss these problems because they just don't enter them right, and they hit enter and they get a totally different answer. Make sure that you can do that for all of these. Okay, your TGA. This might be the most straightforward TGA you've ever had in your life in this class. All right, so the first one, I say, what is the sum of the first 8 terms of this geometric series? Okay, well, there's this stuff. So express your answer in simplified fraction. Easy. No work, no credit. I expect you to have a setup. So basically, if you're wondering what that looks like, look back at how we did in class. The work that I showed in class is what I expect you to show on your TGA. If you want to show a little bit more steps, sure. Maybe a little less, depending on if I show too many steps on simplifying, that's fine. But I should see your work in the setup. If I don't see your set, if I just see an answer, I'm giving you 0 points. I need to see your setup. Second, number 2. It says, consider the infinite series, this stuff here. What is the value of R from the ratio test? So, hey, ratio test. This tells us use the ratio test, the test of convergence. And then what does that R value tell you about the series? So remember if the absolute value of R is, is absolute value? I'm gonna blank if it's absolute value of that convergence test. No. So yeah, if it's less than 1, greater than 1, or equal 1, this is what it's asking you on that TGA. So yeah, very straightforward. Number 3 says use the binomial theorem. So yeah, hey, here we go. The binomial theorem to expand this. What is the sum and summation notation that he uses to, or I don't know why I put he, that he uses to express the expansion. So I give you the expansion formula right here. So to get full points in part A, I am showing you the example of what I'm looking for. So for example, if the expansion was for 3x minus 2y to the third power, part A, to get full points for this, you would just say this equals, and then you're plugging in, K is always going to be 0. 0 to 3, because, well, that is the exponent. Wherever you see n, you're putting in that 3. So 3 goes here, 3 goes here, 3 goes here. And then K stays K. You don't change K, because that's the variable that's actually changing as you actually add them together. This first parentheses is this first term here, 3x. This parentheses is this term, negative 2y. That's it. You're just picking up the parts and you're plugging it in. In class, we didn't actually use this formula because it was easier just to do it the way that I showed it. But on your TGA, you have to at least set it up. And that's what I want to see in part A, is just the setup part. Very simple. 3 points right here. And then part B is you are actually going to show me the work. You're going to expand it like we did in class yesterday. And then I want to see, obviously, once you expand it, you're going to have your final expression, and I want to see that. Just like in class. All right. That's your TGA and the password. You guys want to guess the password is? Hey, it's Pascal with an exclamation point. It is case sensitive. It is capital P. Rest is lowercase. And then exclamation point at the very end. Pascal, exclamation points. How funny is that? All right. So part 1 of the exam is tomorrow. Part 2 is Thursday. And we're starting Unit 2 on Friday. If you'd like to start the test today, you can. But again, please go through the review again by yourself, work them all out to make sure we get the same answers. If you have any issues of typing stuff in, you're not getting the same thing I'm getting, or just maybe you're confused about any of these concepts, message me. I should be free all afternoon, so I can do some one-on-one stuff with you guys if you need be. Message me on Skype, call my office number, or email me. All right, guys. Well, I hope you reviewed something today and learned something, hopefully not new, but just reviewed something. And good luck.